Hello, welcome back to the channel, and today's video is going to be learning how to create a matched pair guessing game in Python using PyGame. Okay, so a matching game, a guessing game, however you want to think of it. This is a pretty common game. You definitely played it as a kid, most likely. You have cards laid face down. You get to flip over two at a time, and if they're a pair, then you get to leave them up. If they're not, then you flip them back over, and you have to go again. And it's kind of a memory-based game. So we're going to just build that in Python. I think that'd be a fun exercise to create a game in Python using PyGame for that. So to get started, import PyGame. If this is your very first PyGame tutorial, then maybe you didn't know that, but you should. It may make you install it, so you can use pip to install PyGame if you need to. More modern IDEs like PyCharm can install it just by hovering over it and then clicking install PyGame. If you don't know how to do pip to install a module, there's tons of tutorial videos out there. Just follow one of those. But okay, so we're going to import the PyGame, and then the next thing we're going to do is pygame.init, and let's just do everything we have to do right now to get the screen up. So we'll go ahead and make a screen width, and we'll set it equal to 600, and we'll do a height, and we'll set that equal to 600. You don't have to put those in variables. You can just stick them in the screen space later, but I'm going to use it for a lot of things, like referring to the total size of the screen. So I'll just make a little section here that I call game variables and constants. It's not a bad idea to add some of these comments throughout your code, because there's going to be a couple hundred rungs of lines of code by the time we're done, so that's not a bad idea. And let's just go ahead and make two colors to start here. Let's make a white and a black, just so that we have, when we throw stuff on the screen, we have a way of showing where different things are, and we'll play around with the style later in the game. Functionality first, style later. Okay, so we've got width, we've got height, we've got a couple colors. Let's go ahead and define a frame rate. So this is how fast the game can run at. We'll do 60, that's pretty standard. And then we'll create a timer. This is a PyGame built-in thing that helps you regulate the speed at which your game runs. So you just define a variable to be your timer, and then once we set up the main game loop, you'll put the frame rate inside of that timer. Okay, so next thing, let's actually define the screen. So I'll just say here, create screen. And we will come back to these sections a little bit more as the game starts getting fleshed out, but we'll just call it screen, and that's going to be pygame.display.setMode, and then it calls for two variables. It calls for a width and a height. And if you didn't create a variable to be your width and height, you would type them in there. So you could just type 600, 600 in there. I recommend having it as a variable if you ever need to look at the size of your screen later. So, and then we'll give it a caption. This is kind of an optional step, but it looks a little better. You just do pygame.display.setCaption, and then you give it the title that you want the window to say. So we'll call it matching game. That's good, descriptive, but you could call it whatever you want. You can call it Pete is cool. You should call it that. Okay, so let's go ahead and actually just throw some stuff on the screen so that we can get a display working. So what you do when you create your main game loop is what it's called, like the code that runs every time the game is active. You create a variable. It's usually just called running. Call it whatever you want if you want, but don't be confusing about it. And then you make a loop, and it's just while running. So anytime the running variable is true, which we set it to be true here, everything inside of this while loop is going to operate. And so, because you should know in programming you can't have an infinite loop, one of the first things you want to do when you create that while loop is set the conditions to get out of the while loop. So you would do for event in pygame.event.get, and then we're gonna basically say that if you press the quit button, it'll stop running. And so that's our condition to end this infinite loop. It just means there's an exit strategy from the loop. So to do that, you do if event.type equals and then PyGame.quit. It's the kind of the built-in for the quit button that's up in the top right corner. And all you have to do is say running equals false. Okay. And then we're going to do a few more things in this loop right now. We're going to say right underneath the loop timer.tick at our FPS. So this is why we did that setup beforehand. We create a variable called the timer, and we created a frame rate that timer would run at. So this is the just way to make sure it only runs 60 frames per second. That helps regulate the difficulty of your game across newer or older devices, so it doesn't become really easy on some platforms and really hard on others. And then another thing that we're going to do right in the beginning, we'll just do screen.fill, and for now we'll use white. We're just going to use one of the colors that we had, and that is good for now. Let's go ahead and do kind of end this loop and end the program so that we can just see that we're getting a rectangle. So pygame.display.flip just kind of throws everything onto the screen in the order that you drew it, and then pygame.quit, and that should be enough to get us a 600 by 600 rectangle. There we go. You can see matching game in the title. And yeah, so not much to it. Let's go ahead and sort of create the box in which we're going to build the game. So if you saw in the intro, there's going to be a bottom bar that kind of says current number of turns, your best previous score, and have a restart button. And then there's going to be a top bar that basically just says like the matching game, or whatever you called it, and then the game will be played in the middle. That's a pretty normal style for like an app or a mobile widget, something like that. So we're going to put all of that drawing, all of the stuff that's kind of constant, we're going to put that in a function that I'm going to call draw backgrounds. So I'm going to say draw backgrounds. It's descriptive enough, I would say. Okay, I'm going to call this draw backgrounds. And we are going to come up and define our function, draw backgrounds. You can call it whatever you want. You could say draw areas, draw regions, whatever you want. But let's actually define it. So let's just start by making 3 rectangles to separate out the 3 spaces. So I'll call this first one top area, top menu. That'll work. And it's super simple. It's just going to be pygame.draw.rect, and then we're going to put it on the screen. We'll make this a black rectangle. It's one of the colors we have. And now a rectangle in Python needs 4 variables. Really, any rectangle needs 4 variables to fully define itself. It needs an x and y start coordinate, and then it needs a width and a height. And so play around with yours and whatever you set it to and see what works for you. But I think that that's going to look pretty good in our space. Yeah, that's enough space to put your text to just say the title of your game. If you want to give the player any instructions, you have a good bit of space to put it in there. So let's go ahead and add a bottom menu. And I put this 0 here. You actually don't need this, but that's a width or a border option. And so let's go ahead and just cancel that for a second. So if you had a variable there, that's saying how thick you want the border to be, but it's still making it a hollow object. And one more thing, we'll use this a little bit later, but there's another thing you could put after there that's the radius of, so if you want it to be a rounded rectangle, you could give it a radius. You actually don't need either of those last two. If you want to just be a solid rectangle with right angles and not rounded corners, you don't need those last two. So that's just a little something about rectangles. Okay, so let's do the same thing for the bottom menu. And that's going to be screen, and that's going to be black again. And then for the X and Y starting position, I'm going to do height minus 100. So here's where using that height variable, if you knew it was 600, you could just type a 500 in here. But on the off chance you ever want to tweak the size of this game later, this is going to make your life a little easier. So we'll do height minus 100, and then we'll make it the full screen width again, and we'll make it 100 tall. And again, we don't need this variable, but if you do leave it as a 0 for the border width, then you're actually saying just fill it in. That means it's going to be a solid object. So let's take a look at that. Yeah, and that looks pretty good. All right, so what that means is that the middle of the screen is going to be like the board space. It's going to be everything else. So why don't I come up here and we'll just make another color so that we can see that we're actually drawing something there. Let's make gray, which is basically the midpoint between all these, between white and black. And let's draw what we'll call board space in our draw backgrounds. So I'll say board space equals, and let's do the exact same thing, pygame.draw.rect. And let's do screen, and now let's make this one that gray that we just made. And for starting X and Y position, it's going to be 0 and 100. And then it's going to be the whole width of the screen, and then it's going to be the height minus 200 in height. So let's take a look. Yeah, so now it's gray. And it does, I mean, this is still pretty basic looking. We haven't done anything crazy in terms of style or background. But this, at least we just drew in the 3 regions of our screen, and we did it quickly, and we did it in a function. So I kind of like segregating out as many different useful but common things that need to run every loop into functions, so your main game loop is pretty easy to read through. You can just stuff all of this pygame.draw.rect stuff in the main game loop. That's valid, but this is kind of a more Pythonic way of doing it. So let's go ahead and do the next piece. Let's add some text saying like what each of these spaces is. So now we're going to kind of be introduced to a few new things that are fonts. So if you're unfamiliar with fonts in PyGame, you do a 2-step thing. First you define the font, and then when it's time to create text, you do what's called rendering, where you define what the text is going to be, what kind of font it's going to use, and then you actually draw it onto the screen later. So without talking about it too much, let's just go ahead and do it here. We'll create 2 fonts. We're going to create a big sized one and then a smaller one. So things like the restart button and the title text will use this bigger text, and then the things like your score reporting will use the smaller text. And you can create as many different sizes of font as you want, but what we're going to do here is title font equals, and then it's pygame.lowercase f font dot capital F font. And then in here, if you have a specific text in mind, a specific font in mind for your game, you can drop a TTF, which is a font file. You can drop it into your game just like you can anything else, like images or music or anything. You can just drop it into your game. Yep, you gotta spell PyGame right. So you can drop it into the folder right here, wherever you have your PyGame folder, and you can define it right there. But I'm using Free Sans Bold. It's built into the install, so I don't have to like drop a font file every time I build a game, and that makes it a little easier for you guys to follow along. So that'll be title font, and then I'll call this small font. It's not really going to be small. 26 is still pretty big, but it's much smaller than the title font. Okay, so you define those up in like your game variables or your screen definition, anything like that. And then when it's time to actually draw the text onto the screen, so we'll go back into our draw menus, draw backgrounds, whatever you called it. Right under top menu, let's create something that we'll call title text. And that'll be, it's going to be title font dot render. So that variable you just made that was your different sizes of font, you call that, and then you do dot render, and then you just give this a few arguments. You say what the text is actually going to be, so the matching game, yay, just like our caption, and then true, and then give it a color. So we only have white, black, and gray right now. We can come back and style this later if we want. But you can see I did that, and it's not on the screen because we haven't drawn it onto the screen yet, but we have fully defined title text. So the next piece is you go screen on the next line, dot blit, and the only way to get around doing this in 2 steps would be putting this whole thing inside of the screen.blit, but that makes it a lot harder for troubleshooting because what you do is you do title text, which is your fully rendered font, and then you give it an X and Y coordinate to be drawn in at. So we'll put this in the top left corner. But if you were to copy all of this and stick it in where title text goes, you've just made it a little bit harder to troubleshoot. It's still valid. Let's go ahead and take a look at it. Yeah, so that looks pretty good. I probably should have mentioned, because obviously these objects take up a lot more space than just like one spot. So when we define a starting point, 10, 20, that's the top left of every one of our objects. So for this top menu, when we gave it an X and Y starting coordinate, it's the top left. And the way PyGame coordinate grids work is the X coordinate increases as you go right, and the Y coordinate actually increases as you go down. So if you have a game where you're doing something like jumping, you actually have to subtract from their Y coordinate to get them to jump. It's kind of counterintuitive, but that's how PyGame works. So just a little side tangent about that. All right, so now we have the title text. I think that looks pretty good. Why don't we just, while we're here, go ahead and do no, we'll save the restart button and the score text for a little bit later, I think. So let's do the really important thing and draw the board pieces on. So I'm going to separate that out from the backgrounds. I'm going to create another function that I'll call draw board. And we can just come underneath our draw backgrounds function, and we'll do another one that we'll call draw board. Okay. And inside of draw board, it's going to be a little bit easier because we're going to do everything procedurally generated. So we're basically going to draw one rectangle, and then depending on how many rows and columns we give it, it'll just populate the rest for us. So let's create a few variables. Let's create rows and columns. And I think let's do something that'll be kind of a challenging game. Be a little more fun to play. You're not going to want to play a matching game with 6 numbers. So we'll do rows, and we'll do columns of 8 and rows of 6. And let's also create a matrix now of just which ones are correct. So the way I'm picturing this is ultimately we'll make a matrix with zeros for our whole board size, and then once they're correct, they're going to be filled with ones. So it's basically just a way of keeping track of which ones have been correct and which ones haven't thus far. We're not into the portion of the game where we need to check guesses yet, so I'm not going to worry about that, but we are going to need a tracker for that later, so I'm just dropping that in there so I don't forget about it. But okay, so inside of our draw board function, let's just go ahead and call the globals that we just made, rows and columns. Let's just call them global so we don't have to pass them in. We're not editing those values, we're just using them. And what we're going to say is for I in range calls. So we're creating a for loop and a nested for loop inside of that for j in range rows. And what we've just done is we've set up something that's procedurally going to go through. We've created something that's procedurally going to go through and check every row and every column. So it's going to run once 0 through 8 or 0 through 7 because counting in code starts at 0 and goes until 1 minus the number that's in here. So if columns is 8, it's going to run 0, 1, 2, 3, 4, 5, 6, 7, and then it's going to go to the next row, which would be 1, and then do 0, 1, 2, 3, 4, 5, 6, 7 again. So this is cool. It's kind of like setting up a coordinate grid just with 2 for loops. And what we'll say is well, that specific piece is going to be equal to pygame.draw.rect, and now we'll create the one rectangle that's going to get written for all of them. So we'll put on the screen. This is going to be in that gray area, so if we make it white, that'll look pretty good. And now here's where, depending on the size that you're going with, you may want to tweak this because we're creating we're doing some functionality that's going to drop every piece in a spot relative to its I and j coordinates where it looks pretty good. So I have messed around with this before. This one looked pretty good for my game, and I'm going to make it a rounded rectangle. But I'll just talk about this really quickly. If you think as we go across every space, and we have a 600 wide space for our x coordinates and a 400 tall space for our y coordinates, you want something that's approximately going to fill that space. So you could just drop in 50s in here or 60s and then play around with it. But essentially I'm saying we're going to put these 50 by 50 rectangles in the space. And so 50 by 8 in our x direction is only 400, and 50 by 6 in our y direction is only 300. So you want to build in some padding so the rectangles don't touch each other directly, and you have some space in between. And so you'll see this I times 75 or 65 plus 12 or plus 112. That's padding, and I'll go ahead and show what happens. So you can see right there, it looks pretty sweet. It made a board for our rows and columns, right? We defined 6 rows and 8 columns, and they're all there. But I got to this point by a little bit of guess and check that I don't think anyone wanted to see in the video. But you can do, like, you could start with just, okay, I'm going to do 50 by 50 blocks, and I'm going to start with I times 50 and j times 50. And if you want to have a grid that's, every piece is touching itself, you could do that. You could do it this way, and then the pluses at the end are just like straight fudge factors. So if you didn't have anything there, oh boy, what I have 75 and 65. If you didn't want to have any fudge factor there, that'd be fine. But then it would be touching the left wall, touching the right wall. You wouldn't have borders. And this plus 112 is because the whole thing starts at 100 pixels down from the top. So this is a way of creating every piece that we want in just a quick for loop, but it does make the coordinate system a little bit non-intuitive. But hopefully that explanation made sense. It might not have. I'm not the best at explaining. But we need to create a variable. We need to create something to track all of the pieces that we have, because an important part of the game is going to be checking when someone has clicked on the pieces. So we're going to go ahead and do this function, board.append, for every piece that we just created. And so this is really great. It's checking inside of the for loop, and it's writing every rectangle, and then it's adding it to a list, and then we can send that list back to, let's not just call it board actually, because I think we may have called the space that we drew the board also board. Let's call it board list just to be a little more descriptive. But now we have a list of all of the rectangles that just got drawn, and we can use that for collision detection outside of this function to see if anyone's clicked on the different pieces. So let's go ahead and return board list, and let's move on. We'll be back in this function when it's time to draw the different numbers for the different pieces, and then also when it's time to check if they're correct and draw green rectangles or black text when it's correct. So we'll be back inside of both these functions as it gets a more complete game, but let's move on from there for now, and let's handle creating. So yeah, you can see it looks pretty good. Basically, we need to start creating the randomly generated numbers, the matches, and figuring out how to hide them. So let's move on from the visual stuff for just a second. And what is it? It doesn't like my blank lines. That's fine. Okay, so the next thing I think that we should do is we'll do what I'm going to call generate board or new board. So basically when the game starts up, I'm going to have a variable that I'll call new board. And on the very first clip of the game, it's going to be true. And so I'm going to put something in here that says if new board is true. And the nice thing about Python is if you have these true-false variables, you don't have to say if new board is equal to true. You probably know this if you're familiar at all with Python, but you don't have to say if new board equals true. You can just say if new board, or if you want to check if new board is false, you just say if not new board. Okay, but what we're going to do in new board is we're going to run this function that I'm calling generate board, and we're only going to run it once, because then right after doing that, I'm going to set new board equal to false. Oh boy, I am not good at typing. Okay, so that's going to lead us to the next function that we're going to create, which is going to be called generate board. And the reason I'm putting this in a function rather than just doing it before we enter our main game loop is I'm thinking ahead. I'm thinking to replayability and wanting to have this like on a restart button. You would want the same code that happens when the game boots up and creates a randomized board. You want all of that code to happen again when you press the restart button. And so we're going to put it in a function. Okay, and we're going to call it generate board. And yeah, okay, global correct. So this one's pretty easy. All we do is say for item in range, and the range is going to be our rows times our columns, which is our total number of spaces, right? And then I'm going to do floor division 2. Hopefully you have designed a game with an even number of spaces. If you picked a board size like 3 by 3, that's going to give you 9 spaces, this game's not playable, so you as a programmer have failed. So I'm saying this up to take the rows times columns, which is total spaces, and divide it by 2. And I'm going to go ahead and do a new list that I'll just, I'll define it here in a second. List is probably a bad, I'll call it options list. And I'm going to call that in global options list, and we're going to go ahead and create that list up above. Options list is going to be an empty list in the beginning of the game, and then we call it in here, generate the board, and we're going to so what we're doing is we're taking the number 0 through however many spaces you have divided by 2, technically minus 1. So you could also improve this by saying, well, I don't want 0 to, let's see, we have 6 by 8, so we have 48. So this is going to do 0 to 23. You could, if you're like, well, I don't want 0, I want 1 to 24, you can set it up that way. You just change your range to be from range 1 to rows times columns plus 1. I'm going to leave it this way. I don't mind having a 0, and stopping at 23 is fine. But I'm making a quick list of all of the options, because if you think about the matching game, we need them all to be used twice. So this is just going to run through really quickly and see how many total numbers we need to have. And even if you're going to go one step farther with your game and make these things like objects or colors or images, something you're going to match other than just numbers, you would still want to do this kind of thing, because you're creating like a list that can be an indexer, and then you reference a separate list. So if you have a list of 23 pictures, 24 pictures that you want to be in use, they're still going to have an index value of 0 through 23 because they're stored in a list. And so you'd still use this kind of thing to look them up. But I am just doing numbers, so I'm just going to use that. And now let's do basically the same thing again, okay? We're going to say for item in range, and we're going to check for the range, rows times columns, and this time we're not doing divided by 2. Now we're assigning a value to every spot on the board. So we're going to say that the individual piece is equal to the list that we just made, the options list. I got to stop just saying list. That's too generic. Okay. And so the list that we just made, the options list, and what's our range going to be? It's going to be from 0, so random.random integer, and it's going to make you import the random module as well, and that's fine. So random comes built in. You probably don't need to install anything as long as you have a fairly recent install of Python, but you may have to pip install or import random as well. But this is going to let us use a rand int, which is going to look up an integer value, and we give it a range. So we say we want a random integer between 0 and the length of the list minus 1, because this is end inclusive. So everything we've been doing so far, it's been okay to just go to the extremity Because it hasn't been end inclusive, it automatically takes 1 off, but the random integer function could use the very last value. So that's the reason for this -1. Okay. And this is great, except as we go through, we don't want a constant length of the options list. So there's nothing inside of this for loop yet that's going to notify the options list when it's been used twice for a specific value. So let's create that next. We're going to have a list that I'll call spaces, and we're going to append every piece to it. Piece. And this is where we're going to keep track of what was assigned at what time. So we're going to create another list, spaces, and we're going to keep track of everything that was assigned inside of our generation of the board in here. So we need to call that in so we know we're referencing it as well. And let me make sure I didn't do any typos because I'm not very good at typing. Okay. Yep. So we're going to append the piece, and then we're going to do another list. And it may seem like I'm creating a lot of lists, but we do need all of them. And hopefully it makes sense once I get this all typed out. But we're going to add piece, and then we're going to do this check. If the newest piece is in the function, the list that we just called used, if it's in there, then we're going to remove that piece from the used list. But we're also going to do options list dot remove that piece. And so there's a second piece to this. Piece, that's probably the wrong word to use. There's a second part to this, which is saying, okay, if the piece that we just did is not in used, then what we're going to do is we're going to add used dot append that piece. So I want to talk about what I just typed in real quick because it's actually super important to the board generation concept. This for loop is going to grab a option from the list of options that we just made. Oh, I gotta call this options list. Okay, so we have a list that's, when this particular version boots up, it's going to be 0 through 23. And it's going to randomly grab one of those, and then it's going to append this new list that's got, you know, an index value. So it's going to say, okay, the very first piece is some integer 0 to 23. Then it's going to check against the used list, which when it starts out is going to be blank, and it's going to say, is 23, 0 through 23, is 14 already in there, whatever was grabbed. And if it's not, it's going to say, okay, well, now used has been, does need to have 14. It's going to stick 14 in the used list. Let's say the very next space is going to come through and grab 14 again, which is pretty unlikely, but it could happen, right? It's random. Well, then the spaces list is still going to append that, and it's going to say, okay, well, the first space was 14. Now the second space is also 14, but we go through and we see, oh, okay, well, 14 is in the used list. So take it out of the used list and also take it out of the options list. I guess technically you could leave it in the used list if you want, but this way is kind of cool. It's actually just only going to keep track of single used pieces, and then once it's been used twice, it's gone from all the lists. And then what's beautiful about that, you go to the next iteration of your for loop, and the length of the options list is going to be 1 less, and 14 is no longer going to be in there. So this is how we guarantee everything being selected twice, exactly twice, and no more than twice. So I hope that makes sense. I know we put a lot of stuff in here. Let's make sure that we call all of our lists globals. Oop, I already called spaces options list, call used, and I think that's all the lists in here. Piece spaces.append. Yep. Okay. So this is great, and at the end of it, it should give us a list of all the values. And just to make sure it's working, because we're not quite at the point where we're ready to draw every piece on there, once generate board finishes, I'm going to print out spaces just so we can verify that what we just did works. So I'm going to run that, and it didn't. Yes, I did mean rand int. Good troubleshooting suggestion, Python. So it's random.randint, not random int. All right. Okay, so I'm actually going to close the board because what I want is down here. But you can see this is pretty sweet. We got 10, 23, 23, 7, 2, 2. I'm just going to scan it real quick. It looks like every value shows up twice. No values show up 3 times. And we have 0 through 23. Okay, so that's really cool. Generate board just gave us a random list of where everything's going to go. Now, how do we use that? Like, how do we correlate those to specific values on the board and display them? So we're going to come back up in draw board, and I'm going to use that list we just made to actually draw their values onto the screen. Ultimately, we're only going to draw the values onto the screen if they've already guessed correctly or if it's their active guess. But for now, let's just get them all showing on screen. It's going to make it a little easier to design the rest of the game in the meantime. Okay, so I'm going to come up to not generate board, draw board. There we go. And we already have this piece of code that's cycling through all of the possible rows and columns. And we might as well just use this as well to draw our piece text on. So we have a list of all the pieces. Let's just create a font for it. So it's going to be small font now, because remember we made I think I called it small font. Oh yeah, it's an underscore. We have a smaller font we made for stuff that's not title size. We don't need this to be huge like the title. And small font dot render. And let's just put in the value. So because we're going to use a variable, I suggest using this formatted string. It's going to be F parentheses or F curly brackets. And it's going to be spaces, but now you need to give it an index value. And if you think of spaces, if you think of it as we just looked at it, it's one long list. And what we currently have is this tool that's iterating through rows and columns. And so you kind of need to think 3-dimensionally about this. The way that you transform this grid, this matrix of values into a linear system of values, well, it kind of depends which for loop you did first. But for this one in particular, to get an idea of how many total spaces in you are, it's actually I times your total number of rows plus j, because j is on the inside. So j is only ever going to be referring to like 0 through 6, right? But the I value could be referring to the first 0 through 6 or 7 through 13 or whatever the next row is. So that may be kind of confusing, but I don't think it is, because if you're programming, you're probably familiar with matrix math. And essentially what this lookup value is checking where you are in your function. And it's grabbing the piece from the linear list of values that we made in spaces, and it's giving it a 2-dimensional address based on where it is in spaces. Okay, so let's go ahead and draw that onto the screen. Maybe it'll make a little more sense. Maybe it'll make sense if you play around with that. You see what happens if you flip the values and how that affects it. Okay, but we are going to screen.blit the piece text, and the location for this is actually really similar to this location, okay, the X and Y starting coordinate. The difference is we're going to want to change our fudge factors just a little bit. So I times 75 is still good, but let's move it to the right a little bit so it doesn't start right on the left of the box. And then let's move it down a little bit so that it's down inside the rectangle a little bit more. And that should do it. One thing I forgot to do in the font.render, you just need to give it true and then give it a color. And I'll just make it gray because that'll show us that it's kind of a work in progress. Let's see if that did it. All right, this is sweet. So we have this pretty good random board, and you need to imagine when the game starts up, these numbers are going to be hidden. They're not going to be visible initially. And until you click them, and then when you click them, it'll be like an active turn, so they'll only be temporarily visible until you actually get them correct, and then they'll stay permanently visible. So we'll move them into another list that we already made called correct, and that'll be what's telling you to constantly draw constantly correct values. So why don't we take a look at how to actually add the guessing mechanism next? Currently there's nothing you can do in this game, which makes it not super duper fun to play. So let's go ahead and down into our event handling, which right now the only thing we have in the event handling is you could quit out of the game. Now we're going to add some stuff that's going to check to see if you are making your first guess or your second guess. So we're going to create two new variables for this. And I'm just going to say first guess equals, and I'll say false to start. And then we'll make us the same variable, second guess, and I'll make it false to start. And so these are just going to check, have you made your first guess? And it is going to be false to start because you haven't clicked anything when the game boots up. And then have you made your second guess? And that's also going to be false. But then the second piece of it is we actually need to create a variable as well that I'll call first guess num. And that's going to be checking what number was clicked. So when you do make a guess, it's going to be assigned an index value that correlates to what space you just clicked. And so we want a variable that can house that. So let's come down into here, enough talking, get coding. And we need a new event type. So it's if event dot type equals, and it's going to be PyGame dot mouse button down, two equal signs. PyGame dot mouse button down. Okay. And that is checking when you click your mouse. And we are going to say for I in range length of and the board list. So we're getting the board list back here in draw board, but we're not assigning it to a variable in the outside world yet. So we'll grab it there and we'll say the board is equal to draw the board. So that way we can use that data in the outside world. That's really useful. Okay, so then in the length of the board that we already created, we are going to say button is equal to board at location I. Just like that. Actually, sorry, index in a list. You want those square brackets. Okay, and we're going to say this button is equal to board.I. And the reason I did it that way is it's really easy to do a collide point with PyGame's built-in collision detection as long as you have an object that's like a PyGame rectangle or circle or sprite. So I'm going to say if that button collides with the point, and what are the coordinates of the point, this part's really easy. You just type in event.position. Because we just said this event that we're checking against is already equal to a mouse button down. So when the event happens, it's going to check the position the event happened at, which is where your mouse is when you clicked. Okay, so we just said if the button collides with the position of the event, we have redundant parentheses. And I'm going to do a second piece here to tell us whether or not it should be the first guess or the second guess. And so I'm going to say, and you haven't already made your first guess. And the first thing we'll do is we'll say, well, okay, now first guess is equal to true because now you have clicked on a button, right? We're saying, okay, you clicked on the button. That's the button.collide.event position. And you haven't already taken your first guess. Well, we'll set that first guess variable equal to true. And we will set the first guess number equal to I. So now we have an index value. This is super valuable. I'll go ahead and print I as well. So when we click it and we don't yet have anything set up to show inside the game that you press something, at least we'll have something in our console window that'll tell us. I'm going to copy all of this down, and we're going to use basically the same thing for the second guess. So if the button collides and you haven't taken your second guess, and I'm going to add another one, actually a couple more, and we're going to check that first guess has been taken, and we're going to check that I is not equal to the first guess number, because we don't want you to be able to click the same piece twice and have it equal to the same number. All right, let me rephrase. There's a lot of numbers in here. The whole point of the game is clicking the same number, but that's the same visible number, not the same index value. This index value is not looking at the options 0 to 23. It's looking at the total list of pieces 0 to 47. So if you click the third row, second column, I think I drew that wrong, but third row, second column, with your first guess, we don't want to have it look like a valid guess if you clicked on the same piece the second time. So that's what this last one is for. This one is checking to make sure you've already taken your first guess, and this one's making sure you haven't already taken your second guess. Okay, so maybe some confusion. If you need any clarity on that, just let me know about it in the comments below. I'll try to explain it a little bit better. But then the second guess number is going to be equal to I again, and we'll just print I when this happens. And that's really all we have to do right now. So let's go ahead and see if it's working. Okay. Actually, I'm going to put one more thing so we can do this a few times. I'm going to put a little checker down here that says if first guess, oops, need an underscore, if first guess and second guess. Okay, so this is what happens when both of your guesses have been taken. And if that's true, then we're just going to set them both equal to false for now. So first guess equals false and second guess equals false. That way, once I've clicked two numbers, it'll set those equal to false so that I can click two more numbers. But ultimately, we're going to be doing a lot more with that. We're going to create another function called check guesses, but I just want to see that it's working. Okay, so I click up here, we get 0. Let's go over to the next column, and we get 6. That's great. So we go down this column, 0, 1, 2, 2, 3, 4, 5, 5, 1, 11. Okay, yeah, you can click all over here. That's awesome. And something you can see, if your first guess is 27, actually, so that was a first guess right there. Let me go ahead and click another one. 11. Okay, so if your first guess is this 6 right here and it's index 7 and you try to click it again, you can't get index 7 again. It's currently checking for a second guess and you can't click the same number twice, which is great. Well, you could click the other 6. You click over here 18 and that's great. So what you can click is the same value on the card. You can find the matching pair, but what you can't do is use both your guesses on the same card. So that's great. We've created something where it recognizes the button click of each individual value on the screen. That's a really good start. So what we need to do, and I'm actually going to move this up above the event handling where our other functions are. And what we need to do is we need to take those guesses, if they're both guessed, and we need to check the guesses. So we're going to create another function because I want to separate this functionality out. And we're going to pass in first guess number and second guess number. So this is where we're going to send it off to get checked if it was correct, if it wasn't correct. Check guesses. That looks good. Let's go up where we're defining our functions, grab a little space for it. And let's create our check guesses, and we will just pass in, and we can call them something different in these local variables than they were called in the outside world, just for easier separation. Because if I were to call this like first guess num, it's going to give me like a warning that name shadows a value from the outside world. So you can just give, if you want, you can give stuff inside of functions different names than outside of functions. Okay, so let's actually say what the check guesses is going to be doing. It's pretty simple, but the first thing we need to do is pass in the entire global spaces list, because now we're checking to see if spaces, which was a list of all the values of everything on the board, and we're checking to see if spaces at the first value is equal to spaces at the second value, right? I mean, that's the only condition that's going to tell us if it was correct or not. So if it was a 6 on, index position 6 and a 6 for index position 18, if those are both equal, then we want to basically modify the correction matrix to have two new correct values. So we also need to pass in our global matrix for correct. And one thing I'm going to do up here, correct, is I'm going to fill it in with our rows and columns now, and I'm going to have them start as zeros. 0, 0, 0, 0, 0. Okay, copy that. And we made it 6 times. I'm going to have to put some commas in there. That's okay. So you may say, like, hey, you've been doing everything procedurally generated so far. Why didn't you do that with like a for loop and move that in 6 times or 8 times? And I don't know if you've ever run into this as a programmer. One of the most irritating things is if you thought you create a procedurally generated matrix, and when you go to modify like spot 1, 1, it's actually what you did is you created an empty row, but then you added an empty row 6 times. And so now when you go to modify one space, it views it as if you put the same object in there 6 times. So if I were to do like a for loop and then this was all zeros, but that was I appended to a list with a variable that was like 8 zeros, then anytime I modify one thing in one of those lists, it's going to modify every row. If you don't believe me, try setting it up with a nested for loop. There are some ways around it. This is actually just really quick and easy, so we're going to do it that way. So now we have a correct matrix that tells you whether or not the variables have been selected correctly, and they're all 0 when it starts because none of them are correct. So in our check guesses, if your guess was correct, well, we need to turn these index values that we have, which is what first and second are, right? They're indexers in our linear list that just goes 0 to 47. And we need to get some values that say what column they're in. So the column is going to be first and then floor divided by the value rows. So if you've never seen floor division, it's a really useful Python tool that honestly feels like it was created for applications like this. Floor division takes the whatever, it's like regular division, but then it rounds down to the nearest whole integer. So for an application like this, you're in whatever column based on the value of the indexer divided by the total number of rows rounded down to the nearest integer. So maybe the easiest way, like if you're trying to figure out what column you are in any of these values, if you divide by how many rows there are, which is 6, right? You're in 0 the whole time because 0 through 5 divided by 6 rounded down to the closest full integer is going to be 0 for all of these. And then for 6 through 11, those values divided by 6 are going to be floor dividing down to 1 for everything. So it's this super useful tool, and we can use it for basically exactly this application to tell us the row and column values of each one. So we have the one-dimensional index value, and we need to turn into some two-dimensionals so that we can modify our array. And then the row is really only slightly more complicated than that, but if you understand what's happening with the columns, then this is kind of just the natural offshoot of that. It's basically what's left over. So if you say it's first minus, and we can actually just sneak the call 1 times the total number of rows in here, or you could type this whole thing out if you wanted to be real clear. But it's basically, you take a look at what that integer was when you floor divide the rows, and I'll do the same thing here, and then I'll pop the game up and I'll explain it a little bit better. So second minus second floor divided by the total number of rows times rows. Okay, let's take a look at it again just so I can explain what's going on here. If you're in the this is technically the 1 row because it starts counting from 0, right? Its linear index value is 19. If you were just to go through, okay, 0, this is 5, 11, 18, or 17, and then 18, and then 19. This 22 is 19. Well, it's really easy to find its column because you just do floor division by how many rows there are. 19 divided by 6 is like 3 and 1/6. Round down to the closest whole value, and it's 3, which makes sense because 0, 1, 2, 3. Okay? Well, if you then take that 3, multiply by how many rows you have, which is 18, and then you subtract that from your index value, so it's 19 minus 18, that'll tell you what row you're in, because it's 0 and then down to 1. So it's a little bit conceptually messy to just look at the code, but if you actually start thinking about it in a three-dimensional space, hopefully that makes sense. So great, we have this row and column value for both, but then what do we do next? Well, the next thing we're going to do is we're going to check and see if it's correct at row 1, column 1. And so if it isn't correct already, and if correct at row 2, column 2, so we're basically checking against the matrix that keeps track of values that are already correct and which ones aren't. And if it isn't correct yet, then what we're going to do is we're going to turn these guys into 1s, okay? And that's going to be really simple. We're just saying, all right, good job, you found a match and you made these correct. Okay, and the reason I added the condition about checking that they're already zeros, you wouldn't be hurting anything necessarily, but since we're going to use how many turns were taken as a metric of how well you're playing the game, I don't want to punish the player if they selected 2 that they already had for some reason. So I don't want to increment their score if they picked 2 that were correct and they already knew that those were correct. You can if you want. Like, you don't technically need this if statement. If you found out that they're correct, then you could add a increment every time. But okay, I digress a little bit. We're going to introduce the element of score now. So that's kind of what I was talking about. We want to keep track of how many turns you took. And so what I'm going to say is if you got it right, good job, we're going to update the correction matrix to show that you got that match, but that still cost you a turn. And if you didn't get it right, well, it definitely cost you a turn. So both of these are going to have score plus equals 1. And to take care of that, we'll call the global variable score. I don't know that I've made that yet, so we'll just drop it underneath here, and we'll say score equals 0. And this is going to keep track of how many turns you've taken total, because then when you play it in the future, you want to see if you can beat your previous high. That'll be how we keep track of that. And I'm going to keep track of the total number of matches that were made. This is going to be kind of a useful check when it's time to complete the game, when it's time to be like, oh, look, you won. We need to check that the total number of matches that have been completed is equal to the total number of options in the original options list. So we're not going to do anything else with it just right at the moment, but we are going to start keeping track of how many correct matches have been made and how many total turns have been taken. Okay, so I need to call global matches as well. And I think that should work. I guess what we'll do for now, just to make sure what we just wrote works, is I'm going to print the correct matrix every time there's a new correct value. So it's going to be kind of ugly to look at, but it'll still be useful. So I'm going to click 2 correct ones. There we go. And you can see right in the matrix, this is all of our pieces. And here's the 0, 0 that we just got that are correct. So let's do one more match, 12 and 12. And you can see there they are in the second row in the, I guess technically that's the first row because 0, 1, but you get it. So that's sweet. We now have this list which keeps track of what pieces you've gotten correct. But we have to actually do something with that. We have to start creating a on-screen representation of that. So what I'm thinking is let's come back up where we're drawing the board, and we already have this routine in here that's checking to see rows and columns and returning the board list, and it draws the correct like number on each piece. Let's just create a second that's basically, I'll use some different variables just to keep things clear. So I'll say for R in range of rows and for C in range of columns. And let's leave it for now. Eventually, I think what we'll do, we'll get rid of them being drawn on in gray at the beginning of the game. We'll just cut that out because we don't want to show the player all of the pieces. But we'll take this same type of command and let's make it black once it's been drawn correctly. So we'll just say instead, let's do black. And let's add an additional checker now. And let's say if it's correct. So here's why I made it so early, because I knew we were going to need it in here. So if we check our correct matrix and at R and C it's correct, well, that's great. That means that the thing has been solved. And so we're going to go ahead and draw a few things. I think we'll take a rectangle that's just like the piece, and I will call it... Actually, we don't need to give this one a name because we don't need to keep a list of them. But I want to create another color now. I want to create green. And these are RGB values. So it's 02550 for green. The G stands for green. And that's one to grow on. We're going to draw a green rectangle, and we're going to put it pretty much in the same spot as the previous rectangle was. But we're going to draw it as like an outline. So it's going to be C times 75, and we'll make it start 2 further to the left, and then it'll be R times 65, and then we'll have it start 2 higher up on the screen, and then we'll make it 4 total, wider and taller. And then what we'll do is we'll give it a width of 3. So really all we're doing is creating a box around the existing rectangle when you got one correct, so that you know that that's already a correct piece. And then we'll draw the piece onto the screen. And instead of I and J now, this is going to be C and R, because we created some separate ones so we could separate off drawing the correct stuff from drawing the wrong stuff. There's no reason you can't use I and J again, or any index value you want. I try to just do things that are kind of logical for me. Okay, so this is going to be C times 75 plus 18 now. We'll put the text exactly where it was already, and then R times 65 plus 120. What I want to see now is every time I click a correct pair, so 21, 21, look at that. It turns green. It highlights. It goes, and that should be permanent. So if we click the next set, 9 and 9, that's awesome. We can also see, because I didn't remove those print statements yet, we can see it's tracking below. Let's click a few that aren't right. So we get a wrong pair, and we can assume the score incremented. That's something else we could print onto the screen if we wanted to make sure. But at least for now, this looks really awesome. And so the game gets quite a bit harder when you hide the pieces, which is what we'll do next. But at least for now, you can see like there's this really cool tracker keeping track of what's been selected correctly. Okay, so 12, I actually don't see the other 12. That's okay. You guys get the idea. Unless, no, am I stupid? Where's the other 12? There we go. Don't answer, am I stupid? Okay. So let's start taking a look at what we should do with the active guesses. So how are we going to do something where when the first number is guessed, we reveal it, and then when the second guess is guessed, we reveal that as well, but only for a set period of time, and then we make them go back invisible. To do that, I'm going to add another color just because it's a little bit easier to see what's going on if you can also see something visually while you're playing the game. So we're going to bring blue into here, and I'm going to make that the color of your actively clicked pieces. So let's go ahead and go under our event handling. So this is pretty much at the end of the loop, and we are going to say if first guess has been guessed, so if first guess, and no matter what, when you do your first guess, we're going to want to draw it blue, like unless it's already been guessed correctly. So that would be something we could add up here. But honestly, if you're clicking on pieces that are already solved, then you're playing the game wrong. So I'm just going to make this an every time thing. Okay, so if the first guess has been made, then I'm going to just steal the piece text that we've drawn in 2 places now. And because it's really like the location's not going to change. But what we need is we need to understand that we've got this spaces index variable that's first guess number. But what we don't have, because we clicked on it and all we've tracked so far is its linear location, is we don't have this piece that tells us its columns or its rows. And so, but what we've already done is the math to figure out how to get those values. So instead of doing all of this in the blit command, I'm just gonna say, okay, drop it in at the location, and I'm gonna come right above it, and I'm gonna make a tuple that's gonna be 2 coordinates for the location, because I don't want like a 300 character line for 2 coordinates. But the first guess number is going to be floor divided by rows, and that's going to give us the column. Sorry if I get any of this backwards. This is a long video. And then we need to give it that, I call it the fudge factor, but it's basically just placing it where it actually needs to get placed. Did I type this wrong? First guess num. Floor divide by the number of rows, and then multiply that times 75, because that's our spacing, and then add 18 to get it off the left. All right, and that's our first one. Yeah, it was just something stupid with formatting. Okay, and then the second one, so that's its X position, and this is pretty much swiped from what we did before, so you shouldn't need all of the math explained again, hopefully. And then its Y position is first guess num minus, and then first guess num floor divide by the rows, and then times total rows. So it's essentially what's left over. And then we need to, I'm just trying to be real careful about getting the right number of parentheses in here. Times 65 plus 120 was our fudge factor. Okay, so location. Let's just click one number real quick and see if we're getting a blue number when we click it. Black. I don't think I changed the color to blue. Yeah, okay. Blue. So this is going to be our actively checked value, 10. Okay, that's pretty good. And then it goes away right now when you click the second one, because we're not doing anything with the second number, and we have immediate unwriting. So like as soon as both guesses are checked, it checks the guesses and then it sets them equal to false. And actually just a really easy way to slow this down. So after both guesses, but we don't want to immediately have the game unlatch them, you can do this pygame.time.delay. And what this is basically going to do is freeze the code for this many milliseconds. So it's in thousandths of seconds. So that is not very long, but 1,000 of them is 1 second, and that'll give us a second to see the second guess, even if it's wrong. So since we did that confusing typing for the first guess, it's a little faster to do for the second guess. And it's basically the same thing, just anywhere that you see first, you go through and you paste in second. So second guess num, second guess num, second guess num. I'm probably going to do something stupid in here, so I apologize in advance. And it's okay to overwrite piece text and location a whole bunch of times, because we basically redefine it every time we use it right before we use it. So let's go in here and see. If I choose 12 and 22, it waits a second, it shows us both values, and then it goes away. But if I do like 11 and 11, it waits a second, it checks them, and then it says, yep, you got them. Nice. So this is how you build like a guessing game that lets you see two numbers, and it'll give you a portion of time to look at both of them, even if they're wrong. So that's pretty cool, and we're getting pretty close to this game being done. I say that, and it's probably like a half hour left, but the main piece of the game is in here. Why don't we go back up to our drawing of the backgrounds, and let's finally put in some additional things like score checking and restart button that are going to make our lives a little bit easier. So we'll go into draw menus. We already have the top menu, the title text. We've already defined the board space. We have the bottom menu. So let's go ahead and grab a few texts. We'll take this title text just so I have a reference point. And we'll make something that I'm going to call restart text. And restart text, okay? And the restart text is just going to be the word restart, and we're going to put it on a restart button. So we don't need it to be a formatted string. We don't need anything fancy. But it is going to go on a black background, so we'll just make it... Oh, not gay. Jeez. I'm going to get in trouble for that one. All right. We're going to make it white, and then we'll put it in the bottom left of the screen. So the screen is like 600 by 600. We'll put this at 10, and then I think 520 is pretty close to the bottom. You might want to play around with this spacing. I'm just going to run it and see if I get the word restart. Yep. So let's put a rectangle around it so it looks a little bit more like a button. I'll just say restart button equals, and we're just going to make it a rectangle. It doesn't actually have to be a button, but pygame.draw.rect, and we'll make that a gray button. So now we're going to have a black background, gray button, white text. That'll look fine, I guess. I'm not a designer. And we are going to want that to be starting at 10. So we'll just move it away from the left wall a little bit. And then its Y position, height minus 100 is okay, but I think we want it to be down a little bit. So we'll move it in 10 as well. Keep a good constant edge. And let's just see, I think 200 is about right for how many letters we have. I think 80 is pretty good height. Let's just check it out. Okay. Yeah, that looks all right. Let's make it rounded. That is harsh corners kind of bumming me out. Let's give it a radius of 5. That looks pretty good. I'd click that button. And we're not going to worry too much about the restart conditions just yet. We are just trying to get it on the screen. And then let's put the text for tracking current score and high score. Let's go ahead and put those both on the screen as well. So I'll call it score text. Score text. And this, instead of title font, I'm going to make these small font because I'll do this. I'll do both right at the same time. So there's restart text, and then here is best text, so your previous best. And these we are going to make formatted strings because, so let's just put a little F in here, and it's going to say format score, and then it's going to have the score. You should have seen that coming. And then for the best score, it's going to say previous best. And then we'll put best score in here. Okay. And we're going to get an error with that because it probably doesn't exist. And instead of score maybe doesn't make any sense. Let's say current turns. So, because score is kind of hard to quantify in this game if you don't explain that it's how many turns it takes you to solve the board. But okay, so let's say current turns, score, and then previous best is best score. And let's take a look. Equals 0. So I haven't put anything in yet to... I didn't think about where we put them on the screen yet. My bad, guys. So let's blit those onto the screen in somewhere that's not right on top of the restart button. I think we'll move them most of the way across the screen. So it's 600 wide. Where are they? We'll put them at 350 and 350. And then let's put the top one at 520, just like the restart, and then 560 should do for the second one. I hit debug, not run. That's okay. All right, so I haven't made the gray text go away yet because I enjoy being able to cheat. It's not cheating, but I made the game, so I can see the pieces while I click, and it's honestly quite a bit easier for basic troubleshooting. So, all right, this is pretty sweet. What we need to do is actually build the restart logic and check when game is over now, because basically other than that, the game is done, and then we'll make the gray pieces actually go away, so it's challenging. So first thing, let's take a look at what we want the restart button to do. And it's actually going to be fairly similar to what happens at the start of the game. So we just need to, another thing, in our event handling, we already check if the button is colliding with any of the game pieces, but now we'll check if restart, and actually we drew that button inside of a function. So let's go ahead and return. It's pretty much the only thing you might need to click, restart button. And let's go down to where draw backgrounds is getting called, and let's just say restart equals draw backgrounds. Okay, so now if restart collides with the point of our event.position, that means that someone has clicked on the restart button, and you wouldn't have done that if you didn't want to reset the game. So we are going to empty out the options list, and we are going to empty out pretty much every list that gets used in this game. Oops. So options list, used, spaces, and then the reason we did that is we are going to set that variable we already made called new board equal to true. And what's awesome is that's already set up to populate options list, used, and spaces. It just needed all of those lists to be empty before we made that variable true, so it would go through and make a new board. And then we're going to set score equal to 0, and we're going to set that total number of matches equal to 0 because we're reinitializing everything. And then we're going to reinitialize our matrix that was checking the total correct values. So again, you could put this in a function just like we did with generating the board. Because you're clicking on the restart button here, I don't really have a problem doing it here. But again, it's probably more Pythonic to put this in a function. So there's my disclaimer. First guess, we're going to set that equal to false. Second guess, we're going to set that equal to false. And then we will set a variable that we have to create called game over. We're going to set that equal to false. And the game over is going to be useful. We're going to come up here to where we made all of our variables and create game over. And it's going to start out false because the game doesn't end as soon as you boot it up. Silly goose. Okay. All right, and so that means when someone clicks the restart button, it should generate a new board. So actually, let's go ahead and check that out. Just take a look at where the pieces are now. I hit restart, it makes a full new board. That's pretty sweet, actually. So I actually have never run this with when you could still see the pieces, but I knew what was happening beneath. Okay, so that's the restart logic. What about game over logic? So it's not as simple as it might seem, but it's also not real difficult. All we have to do is check if matches is equal to rows times columns divided by 2. And since we made that a 6 and an 8, you definitely could get away with just putting in if matches equals whatever 24. You could type that in. I try to make it a little bit smarter, a little bit more flexible whenever possible. But if matches is equal to your rows times your columns divided by 2, set that variable we just made called game over excuse me, set that variable called game over equal to true, and then we are going to draw something on the screen. So I'll just call it winner, and we're going to say pygame.draw.rect. So we're going to put some text on the screen that says, hey, you won, and you won in however many turns. So pygame.draw.rect, we'll put it on the screen. We'll make it gray because it's going to go in that mid section. And let's put it as 10 and then height. Oops. All caps for that one. It's a constant. Height minus 300. And then we'll make it pretty darn wide. We'll do width minus 20. And then we will make it 80 tall. And let's make it a rounded rectangle because those look way cooler than not rounded rectangles. Okay, so let's finish this condition that's checking to see if the game has finished by solving all of the pieces. So we already have said if matches equals the total number of matches that are possible to make in this game, then we're going to set this variable game over equal to true. And then we were drawing this rectangle that's going to go right across the middle of the screen like a banner, and it's going to say, hey, you won in however many moves. So I'll call that winner text. And we're going to put it inside there. So let's make this one title font because it's a big deal. It can take up a lot of space. And let's make this a formatted string so that we can say you won in, and then we'll put the score in there. And then we'll say moves, exclamation mark. Okay? And that's basically all we have to say. So let's just go ahead and say true, and that's going to be on a white, gray background, so we'll make it white. And then let's go ahead and take a look at blitting it. So we want to do screen.blit, and we want to put winner text on there. Sprinkles are for winners, Jimmy. And then we will put it basically at the same spot we put our game over rectangle saying, hey, look, you won. But just a little bit inside of it so that it has a bit of a border again. And then the last thing we should do, this is a game just finished, and we want to check if the best score is greater than the current score. So that's saying you just solved it in fewer turns than the previously recorded fewest turns. And then the other thing we'll do, because when it starts up there's no value in here, you could say or best score is equal to 0, because that means obviously someone hasn't played before. And in those conditions, we're going to say best score is equal to whatever the score just was, because this is really useful, because the only thing they're going to do after a game ends is they would have to go back and they would have to hit restart to play again. And that's going to clear out score, but if that was their best score, then we want to save it. So that's what we're doing here. And then one more thing I'm going to add, I'm just going to only let you guess in this game if it's not game over. So if game over is not true. So we're going to take both of the clicks for your first and second guess, and we're just going to say if it's not game over. And then I'm going to move all of this in. So you can hit restart anytime. You're only going to be allowed to make guesses and increment your turns while it's not game over. And I think that's pretty much it. So let's go ahead and take a look at what we've got. 20, 30, I'll just go ahead while I've still got the numbers on here, and I'll finish one as fast as I can so we can make sure that best score thing is working. And then we'll go ahead and remove the colors, the numbers from getting drawn in when it starts up. It's actually kind of hard to solve when you can see them all. There's too much going on. And so imagine you're playing this game and you can't see the gray numbers. And so you'd be clicking on a lot of mismatches and you'd only be able to see them for a second before they go invisible, before they go away. 3-3. Almost got it solved here. I'm doing really well at this game. I don't think anyone's ever going to beat this high score. 11-11. 8-8. 21-21, 16-16, 2-2, 13-13, 20-20. So that should give us, there we go. You won in 24 moves. That looks pretty good. It's right in the middle of the screen, catches your eye. I can no longer click on pieces. I can't change my turns, but the previous best updated to 24. And if I hit restart, the board recreates, turns goes back to 0, and my previous best holds true. So really the last thing to do before you would want to let someone else play this, well, first off, you can get rid of every place that you had prints. They don't hurt anything, but they were just for us while we were writing this for troubleshooting and to see this different states of different things. And in general, when you're writing a game and you're having issues seeing where things are going wrong, just drop a print statement to show what you'd be expecting to see there, and it can always tell you what's going wrong. Okay, and so the last thing, I already talked about this, to make it to where the gray numbers don't populate right when the game is created, I'm just going to comment out those 2 lines. I did it with these 3 quotation marks, the 3 single quotation marks. You could do it by dropping a £sign on both, so you could do it like that as well. It doesn't matter. Either case is going to get rid of that code, and now when you boot it up, it's invisible. So, okay, we start clicking around 3, 0, 14, 3. Let's see if I can even get 1. I think I found a 4 already somewhere. I don't know. I don't want to make you guys just watch me click around for a really long time. Okay, so there we got 1. And you can see if I hit restart, those were just 9s, and now only one of them's a 9. But we get a different board every time. And this is pretty fun. You could give this to someone. You could play against someone and say, like, look, I just did it 2 times. I got it in 60 turns. Now you go. There's so many different things you could do to take this game to the next level, like stylistically. You could add sound effects. You could punch in a little animation to where it looks like a card is flipping when you click. You can play around with every setting that we talked about. You can make it to where these are visible for longer. You could import images instead of just having numbers, or you could do text or things like that to make it more like flashcards. But in general, this is how you create from scratch a matching pairs guessing game in Python. And I hope you found it useful. I thought this was a super fun tutorial, a really good exercise, and I really enjoyed making it. So if you've found anything on this channel useful, be sure to subscribe to the channel, like the video. It helps me out a ton. And if you have any questions on what you saw in this, or you want any clarification, or you want to see something in particular in a future video, just let me know about that in the comments below as well, and I'll get back to you as soon as I can. And as always, thanks for watching, and good luck with your code. Thanks. Bye.